morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with Everest Networks. Today's host is Ryan McKenzie. He is their North American Director of Sales, and he'll be presenting today. If anyone has any questions, please feel free to send them in the question box to me, and I'll ask them of Ryan at the end of today's presentation. Ryan, thank you so much for being with us today. Appreciate your time and your presentation. I am finished for now, so go ahead and take it on over.
Thank you, Julie, and thank you everyone for attending. It's a pleasure to sit and to share some technical information today, and appreciate the opportunity that Microcom has afforded us. We at Everest Networks very much value the partnership that we have with Microcom, and hope that this presentation is found useful to those that decide to partake. Again, my name is Ryan McKenzie. I've been in the wireless industry for about 18 years now. Love wireless. Have been involved in anything from outdoor wireless, making long distance microwave shots, to indoor wireless in hospitality, in education, and in stadiums and arenas as well. And so today what we wanted to talk about is jumping into some of the more specifics that we need to watch out for as wireless engineers and as network managers when we look at Wi-Fi in some specific spaces: hospitality, retail, education, really any indoor location where we have a large gathering of people. So with that being said, we'll jump in. And again, I encourage you to ask any questions in the chat window, and we'll address those questions at the end. So first of all, let's define. Let's talk about what we mean by Wi-Fi in education, hospitality, and retail, and what the general trends are in the industry. So as we've probably all seen, if we're in the wireless industry for any amount of time, Wi-Fi is no longer optional in these types of environments. It used to be that you could get into a hotel and Wi-Fi was, an added bonus. Well, now it's a necessity, no different than having electricity or a hot shower. And so with that comes some specific design requirements, and it is also becoming much tougher to design a proper wireless network that will deliver the type of services that are needed. So we see a need for Wi-Fi every day in these types of environments, for guest or student access, for the general public. We're also seeing a much higher need for point of sale, for taking credit cards and internal sales operations. User and inventory tracking. This is becoming extremely important as owners of venues want to understand not only their inventory, but also, more importantly, in a lot of cases, users. See how a crowd moves and tracks throughout a venue to see, for example, in retail, if you understand the traffic patterns of your users, you can then create digital signage or rent fees based on where the bulk of people move. Digital signage, everything is becoming digitized nowadays. So there's more and more devices out in the field where we need to provide information, advertising, etc. And so Wi-Fi is becoming a standard backbone that people can use without having to pull a cable. Cellular offload is another big one. In a lot of these large environments, like a large hotel, in universities, cellular is no longer an option without putting expensive equipment inside. So a lot of the carriers are now looking to Wi-Fi providers as well for cellular offload. So these are just some of the applications that we see in Wi-Fi every day in these types of environments. And again, it is becoming more and more of a requirement that the wireless network become not only reliable, but it is also efficient in moving that data. It used to be years ago that we had, somebody would just go down to the local computer shop and buy a low-cost Wi-Fi router or access point, and that would be sufficient. And nowadays, that's just not the case. You look at the lecture hall on the bottom, and you've got students that are coming into lecture halls nowadays, not only with one device to take notes, but also usually 2 to 3 other devices, mobile phone, tablet, smartwatch that all need to be connected and working. So there are very specific design requirements that need to be considered as we go into these spaces, and that's what we'll talk about today. With that in mind, we've all seen the general trend if we've been in the wireless industry for long, and that is that wireless is not going away. In fact, wireless is getting bigger and bigger, and we're having to design more and more robust networks in order to keep up with consumers. It used to be when I first got in the in the hospitality wireless world, that was about 10 years ago, that the standard was you planned on 3 devices per guest. So if you had a room with 2 guests, you had to plan on having 6 devices in that room. It's projected now that in North America by 2021 that the number of network devices per person could be up to 13 as we have more and more devices that need to connect. And so with that, it becomes, again, important for us to design our wireless networks with that in mind. Now, one thing we want to talk about here to set some of the stage is that the coverage versus capacity discussion. In the last 5 to 7 years, really, WLAN engineers have really had to modify their approach. When wireless first came out in 2000, and as it went through about 2010, we really were installing wireless just to provide coverage because there wasn't a large number of wireless users, and so all we really needed to do was make sure that we got the coverage to the corners of the buildings, to the last room at the hallway, for example. And as long as we could get a signal, then that's all we needed to worry about. In the last few years, that's changed dramatically with users carrying multiple devices, with those devices needing to stream, with those devices needing to make video calls live. We've had to change that to a capacity model. So nowadays, when you look at an environment where you're designing a WLAN system, a lot of times we worry less about the square footage that we're trying to cover and more about the data capacity that we're trying to provide. This also becomes extremely important as you're taking into consideration the limitations of 5 gigahertz, which is the only frequency available for 802.11 AC and AC2, which is the standard right now. Yes, in this discussion, we're not going to bring up 802.11ax. 802.11ax will help with that in the future because we will get back to some 2.4 that we can use. But 802.11ax is still one of those technologies that's a year and a half away before we start to see some real deployments. So we have some access points that are 802.11ac, but AX, but we really don't have many client devices yet. So it's one of those future things. So as we're designing networks today, we still have to design with the tools that we have. And right now, 5 gigahertz is the best way to go in a high density environment. As a WLAN engineer, when we're designing networks, one of the major considerations that we have to consider is how many clients per AP. We've all talked about this. We've all batted numbers around. There's different rules of thumb. There's different schools of thought. But the standard is that if you want a good, solid network, that you need to have somewhere between 25 to 30 to maybe 50 if you're pushing it, client devices per access point. Once you get beyond that, then you start to get to the limits of the 802.11 specification and also the hardware limitations. And so that brings us back to this idea that we need to, as more devices are present, we need to have more devices, more access points in the area in order to serve those client devices to increase that capacity. So as we've seen over the years, Wi-Fi technology has really not kept the pace with the user. So as more wireless devices and clients come into an area, standard Wi-Fi solutions have had limited answers. The only real option has been to increase the number of access points. In most cases, these are omnidirectional access points. And with the omnidirectional access points, what that does is that, number one, it's going to increase the wiring and installation costs because now we have, instead of 1 or 2 APs for a lecture hall, now we have 5 or 6. So we have increased installation costs, plus we have RF interference that increases as well in an omnidirectional type of environment. And of course, with the support and maintenance costs, every point that we have a device installed becomes more in cost to maintain and support. So when we're looking at education and hospitality deployments, we want to look at, it's important to have the tools in order to provide the best service for the type of environment you're going into. So there's a couple of rules that we want to talk about on the left-hand side, and these are rules that will apply in all wireless environments, but we want to specifically try to apply them to these three locations, education, hospitality, and retail. Number one is create separation. In separation in wireless, what we mean by that is RF separation, meaning different channels. We mean physical separation, meaning walls or distance. And if at all possible, client separation. And the idea here is that as the way that the 802.11 specification is written, when a Wi-Fi device communicates with a wireless access point, it has to go through a number of steps, including clear channel assessment, et cetera, et cetera. And so the more client devices you have in an area, the more access points that you have broadcasting on the same channel, the more latency and lower throughput you're going to have. We've all seen that as we have co-channel interference, as we have neighbor channel interference, et cetera. So utilizing the walls, utilizing barriers, cubicles, whatever we can to stop RF signal, that becomes an important part of wireless design and RF design in these types of environments. In addition to that, using directional antennas where applicable. In an environment where you don't have walls, you don't have physical barriers to separate that RF, to create that separation, then a directional antenna becomes extremely important. The directional antenna has two real functionalities at this point. With a directional antenna, not only do we isolate that signal, a directional antenna will basically act like a megaphone. It will direct this signal into a much smaller area as opposed to pouring it out in a large area. So it isolates and focuses on a client device. But in addition to that, antenna reciprocity will increase both the uplink and downlink rates. If you haven't looked much at antenna reciprocity, we're not going to take a lot of time to talk about it today, but the idea is that in a link budget, when you're configuring a link budget and you're looking at the access point and a client device and what is needed in order for those two to communicate, there's two ways to make a signal better, and that is to either increase the TX power on both sides, on both the access point and the client, which in this case, you're usually not able to increase the TX power on a client side. A client device is usually a mobile phone. The other way to increase that link budget is to add a directional antenna on either side. By adding a directional antenna with a higher gain on one side, meaning the access point, that will also increase the uplink on the link budget from the client side. So it's one of the easiest and cheapest ways in order to create a better signal coming back from the client device as well. Lastly, one of the most important things is to use low TX power and to also increase data rates. So in an environment where we're putting a lot of access points, where we have a lot of wireless signal, a lot of times you get sticky clients, and that sticky client is a client device connects to one AP at the end of the hall, and as it moves towards the other end of the hall, it instead of moving from one AP to another, it actually stays with the first access point that it's associated with. So there's a number of ways that you can get around that, but one of the easiest ways is to use lower TX power on your access points in order to create smaller cells. And then to also raise the data rates. And by data rates, I mean, when you look at the association rates, usually in your 802.11 AC, you have like a 6, 12, 24 data rates that they can associate at. By removing the lowest data rate, that's going to encourage your clients to roam faster and to move off of the access points. Now, one of the tough things about education and hospitality today, though, is that, as you see pictured on the right, you need to have a variety of tools because it's not just cookie cutter. Now, in a hotel room or in small classrooms, for example, you might have the ability to use those physical separations and have an access point in each room, for example. That is the design specification that most vendors offer now, which is utilize the physical walls and put one access point, low cost access point into each room. However, in a lot of these spaces, you also have large areas. You have, pictured below, you have a convention hall. presentation room where a lot of higher end hotels will have conventions, and that same idea won't work there. That same technology won't work, so you have to have different tools in your toolbox in order to tackle both environments. So with that in mind, we want to talk a little bit about what Everest does different and what we consider our HD Wi-Fi solution. And with the Everest solution, hopefully by the end of this presentation, you'll see that we offer all the tools that you would need to go into one of these environments and provide both a low-end, low-density solution as well as the high-density solution. Our HD Wi-Fi solution, we have a number of access points that have 4 concurrent radios. We have software steerable antennas. We have advanced military spec hardware to reduce interference, and then we also have some artificial intelligence that's built in to direct users to do load balancing and also direct antenna beams. So let's look briefly at the Everest product lineup to give you an idea. So again, we're talking about toolbox. As a W-line engineer, when you go into an environment, you need to provide the best solution possible. And usually that, again, not everything's a nail and not everything requires a hammer. Sometimes you need multiple tools with multiple options. And I apologize, it looks like this is not showing up correctly on some of these for some reason. We've got some artifacts. We won't go through every single one of these, but you get the idea that on the left-hand side, we have our high-density Wi-Fi solution. In each of these cases, each access point has 3 5-gig radios, as well as 1 2.4. Our standard Wi-Fi is designed for the low density environments, our environments where we need to go into 1 access point per hotel room or 1 access point for 2 to 3 hotel rooms. So lower cost, lower number of simultaneous 5-gig radios, for example, and also a lower number of max associated users. And again, these max associated users that we show at the bottom here, these are based on real world examples. We're not trying to pull a marketing ploy here. The marketing team would want us to put this at 1,500 users or 500 users, and these numbers are based on real world examples where we've actually tested this and seen this happen. So what do we mean by 4 radios per access point? Most access points nowadays are pictured on the left, have a dual band scenario. In the dual band scenario, we have 1 2.4 and 1 5-gig radio. And as we talked about earlier, in most cases, you want to have 25 to 30 devices per access point. In some cases up to 50. That means that you're basically dividing that up. Let's take 50 and divide that up, 25 devices per radio. As you can see, that becomes tough to do in a high density environment because that just means you have to increase the number of those access points. At Everest, what we recognized is that we have more density, more wireless density, and while increasing the number of access points is seemingly easy to do, it's a much better way to go by increasing the number of radios in a wireless access point. So our high density access points have 3 5-gig radios that are completely independent, plus a 2.4, and that gives us the ability to handle much more, many more client devices, and to provide a much more clean environment with a lot less interference. One of the ways that we do that is by the directional antennas, the high quality directional antennas. This gets back to what we talked about earlier about utilizing antennas to create that separation. Wi-Fi and light follow the same rules, and so we've seen this in the city environment where you've got an omnidirectional type of light where you have light bleeding everywhere, and the more you focus it, just like taking a mag light and twisting the lens, you focus that light. What that does is that takes the energy that's there, in this case our RF energy, the Wi-Fi energy, and focuses it where it needs to be. So in a standard access point, a standard omnidirectional Wi-Fi access point, when we're utilizing Omni, it's very easy to deploy because we have a set kind of coverage area. It covers basically a whatever 50 to 100 foot radius, depending on what type of installation you're in. However, what that does is it bleeds that signal everywhere, and it doesn't direct it where the user actually is. So in our HD Wi-Fi solution, we specifically focus heavily on our directional antennas. We have multiple directional antennas. In fact, most of our access points have at least 16 antennas inside the AP. And those 16 antennas are designed to specifically focus and spotlight a user, giving them the best throughput and the lowest latency. This kind of gives you an idea of what that looks like. In a traditional Omni AP, you have a lot of wasted energy, and that access point is also open to a lot of interference from other wireless devices and other wireless access points, opening yourself up to co-channel interference, to neighbor channel interference, etc. However, in the Everest multi-beam, we have 4 radios and 4 antennas. And again, because it's 4x4, that's where we get the 16. We have multiple antennas that are all very directional. That gives us the ability to spotlight and focus that signal on a client, meaning that that gives the client device a stronger signal. Utilizing antenna reciprocity, we've increased the uplink from the customer, gives them as much as a 20 dB difference on the uplink, and gives less interference because now it doesn't have the interference coming from neighboring devices. And that translates overall into up to 3 times higher throughput. And we've seen that in the field multiple times now. One of the ways that we do that, it's important to talk about the RF environment and how we manage and how to understand directional antennas. Some of the things that we do different than a standard directional antenna, because there are a number of directional antennas that are out there. Everest utilizes a phased array antenna. With our phased array antennas, we have multiple beams that we combine together in order to give a broad coverage area. And with that, we offer a pan and tilt option. That pan and tilt means that by software, by our controller software, I can actually move that antenna beam to cover specific areas. So perhaps as the crowd moves, I can move that beam to where the crowd is and not waste RF resources in an area where it doesn't need to be. That, of course, gives us the spotlight coverage. So when we spotlight that RF energy, now we're not wasting that energy. We're focusing it like a laser beam right on the area that we need, where we need it the most. And again, because of that antenna technology, with the directional antenna, we have longer range and higher throughput. And this is something that's interesting as well, in that we all know multiple in, multiple out MIMO, that relies on, and multi-user MIMO, that relies on multiple streams or multiple polarizations. And the standard is horizontal and vertical. Everyone does horizontal and vertical. Some do a 45 degree slant, but we found, in real world, that doesn't offer enough separation. And so we're really stuck in standard Wi-Fi with 2 polarizations, usually horizontal and vertical. With our antennas, we actually introduce an orthogonal polarization. That orthogonal polarization is something that will be employed by some in 802.11ax. It's a technology that's been used by satellites for years and years and years. And we are the only Wi-Fi company that offers that orthogonal polarization, giving us a true 3 polarizations that we now can offer to a client device, which the more streams you offer, the more throughput you have. So what does that translate into the real world? So in the real world, we go back to this diagram that we started with. Especially as older networks are being upgraded, we found this again and again in the real world, where we have a very few number of access points built out to the coverage designation and not necessarily to the capacity. And so we find a lot of retrofit users saying, hey, we need to upgrade our Wi-Fi. We know it doesn't work. We don't know how we need to upgrade it. And with the standard tools that are on the market today, a lot of people are doing what you see on the right. So with standard Wi-Fi, they're going in and they're taking what was 6 APs to cover an entire area, and now they're jumping that up to 24 APs, meaning that they're adding more APs, they're pulling cable, they're adding labor, they're adding support and hardware costs. Because of our ability to increase the radio density as opposed to increase the access point density, in a lot of cases, we're able to reuse the same locations and the same cabling, saving the end user and the integrator money and time, but still giving a benefit. If you look at the numbers, this is the same number of wireless radios covering the area. But again, in the case of Everest, we have only the 6 access points, but we have 4 radios per access point, giving us that higher density needed without increasing the installation costs. Now, of course, none of this would be possible if it was just omnidirectional antennas, because you'd still have the same problem, because it's all about separation. So in the environment on the left, again, it's requisite that you have highly directional, high quality antennas that will direct and spotlight that signal, creating this microcell image that you see on the right, but on the RF scale. If we look at some real world examples, this is a real world example where we were asked to come in because a customer had some standard dual band access points sitting on the elevator bank. You can see those in blue, and they just weren't getting the type of throughput that they expected. So we went in and actually reduced the number of APs by putting 2 APs on opposite sides of the room and using the directional antennas. And what that did is this office staff now of almost 200 completely relies on the wireless and is no longer chained to their desk, which is what they were before with the standard Wi-Fi. And it just comes down to the standard Wi-Fi before was not giving them the proper coverage. It had co-channel interference, et cetera, and was not designed to work in this type of environment. If we look at some other design ideas, and again, these are just to give you some real world examples of where we've applied our product. In a stadium environment, we have applied this where we have spotlight antennas above the fan, above the user. And so you can translate this into a convention center, a convention hall, a ballroom in a hotel. And what we are able to do is provide a very, very controlled and clean RF beam to a specific area to cover that area, all from the one access point, and then have multiples from that same area. So in this case, you're seeing 3 individual beams coming from the one access point, and the darker areas is where we have a little bit of overlap built into it. Here's another solution where we have another stadium where we have deployed the same type of solution where we have 3 beams covering an entire section, and again creating that microcell without having to install access points down underneath the seats or in the rails. Now, of course, all this is great, but we also need to understand that in this type of environment, in education, retail, and hospitality, we also need to have the control and the capability to understand what the network is doing, and it also needs to be at a price level that's competitive. And so I want to take a second and talk about the wireless management system and give you a quick view into what it offers, and hopefully give you an idea as to what the entire package would look like. So out of the box, the wireless management system gives you that single pane of glass. We have a dashboard that combines and aggregates all of the client information together to give you a quick understanding of what that network health is looking like. So we have client performance data analytics as well as timeline charts. We can go back and we can look at signal strength, at MCS rates. We also have an automatic event report generation. This becomes extremely valuable when we talk about having, for example, a convention come into a high-end hospitality environment, and we need to see the number of devices that were connected, how much throughput we provided, because in a lot of cases they have it's been a financial obligation that the customer has had to put up, and so we want to show to that customer that we've been able to provide that that type of service. So we have built-in report generation that gives that type of information. In addition to that, and this is probably one of the most important things that I could hopefully leave, is that our software is extremely scalable and designed to be very flexible. So as a user, if you've never used our wireless solution, I would recommend going to our website at everestnetworks.com. You can download the software for free. It is a standard ISO, and so you can install it on your own hardware server if you'd like, or we have the ability, and we have a instruction manual there that allows you to install it on a virtual machine. So you could run it on something as small as a laptop and handle just a couple of access points, maybe 5 to 10 access points. But then you could also install that same software onto a high-end server and control. In multiple cases where we've done it, we've managed networks that are up to 70, 80,000 users at a time, all utilizing that same software and just installing it on different hardware platforms. So the software becomes, again, it becomes an asset because it's extremely scalable, can work for all of your environments, whether you're talking about a simple home or small office environment, all the way up to large scale major venue type environments. In addition to that, we have a built-in visualization of the network which is designed to give immediate feedback on what the network is doing and the health of that network. So as you go into, say, a campus environment for education, for example, the software is designed with the idea of buildings and floors so that you can set up each individual building separately and then each individual floor separately, place those access points on the map, get a visualization of what your network looks like, and then track the clients through that environment, seeing not only client density, but client throughput, trouble areas. You can see some trouble areas start to highlight in orange as the density increases, and giving immediate feedback and also historical feedback. You can actually do playback on this and see historically what has happened up to 6 months after events, in order to understand if there was troubleshooting issues that you needed to take care of for future events. In fact, one of the new features that we just added is a client tracking, where we can actually go back in time and pick a specific client and see them move throughout the venue. So I didn't have I didn't want to put a video on here. I just wanted to do a couple of screenshots, but this actually shows you a client device as we've highlighted this MAC address. And we played this back, and these are the individual screenshots as it moves from one access point to another. And again, this does a couple things. Number one, it helps you to troubleshoot what the client is seeing if you have a troubled client that is struggling with connecting. And number two, and this is probably more important, is it verifies the proper AP configuration. As we talked about earlier, in these high density environments, you want to create that separation. That separation has to come from walls. It has to come from the correct TX power or data rates. And so if you have an AP network configured incorrectly, then what you'll see is client devices skipping from one access point to another access point 2 to 3 down the line, as opposed to what we see here is we have a client connecting to one access point, quickly moving to the next access point as it gets closer, and then moving to the next one beyond that. So you can actually track and see and help to highlight spots where you are perhaps misconfigured or could increase the efficiency of your network. And lastly, we don't want to spend a lot of time on this. We've already spent quite a bit of time. Wanted to mention our third-party plugin capabilities. So with third-party plugins, we have the optional available packages such as Captive Portal. So we don't have Captive Portal currently built in. We have Captive Portal through Purple, through Kiana, through Green Zebra, through quite a number of others that allow you to do social media login, to do standard terms and conditions, etc., in order to give your customers and the venue owners the type of information that they want. With that, some of those third-party packages give us true location-based tracking. So in retail, it's extremely important to understand, again, trends, where your customers are, what the traffic patterns are, and with one of those third-party applications, we can actually show that trend and see that historically as guests move in and out of a convention hall, for example, to see what the highest populated ingress or egress points are, for example, and start to predict trends based on that information. And then lastly, cellular offload. Again, we touched on it briefly here, but I don't want to skip that because that's an important one. Again, cellular providers day by day are looking for ways to increase the capability, especially in these types of buildings. And so they're going in and installing a large number of highly priced equipment in order to provide LTE and 4G coverage, and of course 5G is coming soon. And what they are finding very quickly is that they need a wireless provider. A Wi-Fi provider in a lot of cases can do that a lot cheaper and a lot easier. So we have cellular offload that's also built into our system, as well as Hotspot 2.0, which allows us to back end into any carrier solution and offer that data offload. So I hope that you have enjoyed this. I hope that you've gleaned something from this. Again, this is designed to be just kind of a quick overview of some things to consider when you go into education, into hospitality, and into retail. And my message to you would be, please reach out. We appreciate your time, and we hope that you would, consider doing what many of the pros have done. We have a pretty long history of going into high density environments, tough RF environments, and have proven our technology over time, and we hope that you can follow that trend and upgrade to HD Wi-Fi as well. So with that, I will leave you with my contact information and say thank you. I've got my information on the screen. Please feel free to copy that down and reach out to me directly, at which point I would be happy to engage with the Microcom rep that you normally work with and help come up with a solution that would hopefully fit what your needs are. And with that, I'll turn it back over to you, Julie.
Thank you, Ryan, so much for that presentation. I can tell you we for sure enjoyed your presentation. I've got some questions here for you. Let me go ahead and get started with the first one. How does the out-of-warranty device work? Can they still get replacements for certain parts of the device?
Out-of-warranty devices, so it's a great question. So number one, we have a standard 1-year warranty, so any defects within the first year of the life of the product will be replaced under standard warranty. We also have an extended warranty that we offer that can extend that warranty for as long as you want to pay for it, and that's per device if you want to have that. It's important to understand we don't have any long-term support costs. There's no long-term support or subscription licensing fees as well. So once you buy the access point, it's yours forever. As far as out of warranty, if we have an out of warranty device, right now there is no, we might change this in the future, but right now everything is self-contained because of the advanced antennas and the advanced technology. We don't have external connections. We find a lot of field issues with that, and so right now it would be a replacement from the factory, and so we would evaluate that independently and provide pricing for just individual component replacements.
Excellent, thank you, Ryan. Next question here for you. For the Everest HD Wi-Fi, does this work as a mesh where a user only connects to one SSID?
That's an interesting question. So might want some more definition there. So we should clarify that it does not do mesh, meaning that each access point does have to have a wired connection. So we don't do any meshing between our access points. That being said, if I understand correctly, what the customer is asking is that we can actually broadcast multiple SSIDs on every radio and every access point. So as a user connects to, let's say, the free and open Wi-Fi, they would actually connect possibly to any of the 4 radios that are in that access point. And then also as it moves towards an area where another access point covers, it would transition over to that access point, the client would. And we have back-end software that encourages and helps to move that customer to do the load balancing for that. So it is not a mesh system. It is not designed to be mesh, but it is designed to propagate multiple SSIDs across those multiple radios. And again, probably the most important thing to understand here is that each one of those radios, the 2.4 and the 5 gig, have completely independent control. So you don't have to broadcast the same networks over each one of them. In some cases, we have one that's designated just for ticketing, for example, or point of sale, and that's just for those one devices, and that gives a dedicated resource versus the other 3 radios in the box are dedicated to, for example, the fan facing or the guest facing. I hope that answers the question. If there's further follow-up, please ask.
Certainly. Thank you, Ryan. Next question here for you. Are the antennas on the Everest devices built in, or can we remove them and replace them with a third-party AP antenna?
They're all built in. They are. There is a lot of technology that we have built into our antennas. So in fact, it's a lot of it's based on the F-18 antenna design. The F-18 has an antenna design where it actually moves and directs the antenna signal. It's not just a standard broad beam antenna. And so with our access points, all of our access points are built specifically for our antennas, and they are not able to be removed and added to a third-party antenna.
Thank you very much. Next question here. Are they IP67 rated?
All of our outdoor APs are, yes. We have let's see, 4 outdoor access points that we offer, from ultra narrow, from a 15 by 15 degree beam, all the way to a wide beam that's closer to 160 by 160 degrees, and again, of course, varying in between there. And all of those that are outdoor rated are designed to be IP67. So yes, fully waterproof and fully capable of handling any type of weather.
Excellent, thank you. Next question here for you. Do you have specification sheets for each device to customers browse to see the maximum distance and angle for each access point or device?
Yes, we have a specification sheet for each one of our devices. If you go to everestnetworks.com, at the bottom of the page there, you will find a product page for each one of our access points, and there you'll see full specifications. I'm trying to think. I'll be honest with you, I don't think that we have all of the antenna variables built into those spec sheets. For example, the 1004 WRE and WRI have a combination of 32 different antenna combinations that you can get, and so we don't have each one of those outlined, but you can also go to the support section of our website where we have a instruction manual also for each one, which is a detailed, I think it's 30 pages per each access point, and that gives more detail. So it does give you the type of beam information that you're talking about.
Excellent, thank you. Next question here. Do you see indoor applications with these units like domes and enclosed arenas?
Yes, we've installed in multiple, and have found that our solution is much preferred to many others, because in an indoor environment like that, you have to worry about reflection. It's a big problem, and what we have found, we've got a handful of permanent installs already in indoor environments, and we have found that by having a very directional antenna and controlling the power and the data rates like we talked about here, that we're able to control that reflection and actually give much better service than, for example, an under-seat type solution. So in a lot of cases, we're actually being asked to come in and cover the floor of a arena, for example, where the current Wi-Fi solution can't. So a lot of current Wi-Fi solutions are under seat or in rail, but you get a concert in there and they can't cover the floor without pulling out temporary access points and strapping them to temporary seating. And so in a lot of cases, we're actually being deployed from the catwalk and covering the floor from above, and end up providing, in the cases that we've done, end up providing better wireless for the floor than the fans that are in the seats in a lot of cases.
Thank you, Ryan. You may have already answered this next question, but I'm gonna throw it out there to you anyway. It says here, what is the purpose to point the devices down and not under seats or through the railings?
So there's really two main purposes there. The first one is better RF propagation. So and again, we're talking about a stadium or arena environment. In this case, it sounds like in a stadium or arena environment. In fact, we could talk about this for another 2 or 3 hours if you'd like to. In an under-seat or an in-rail environment, you have a wireless access point that really serves about 15 to 20 people very, very good. In other words, if you're sitting right next to the access point, right above the access point in an under-seat, then you got great signal. But the further you get away, the worse that signal becomes. And so that forces multiple access points to be installed under seats. Now, that's number one. That becomes a tough thing to maintain, because now you have a huge number of access points that you are pulling cable to. So that becomes an expensive installation, and maintaining that becomes expensive, because in a lot of cases you have 3 to 4 times more access points than is needed. But then number two, one of the problems there is in a partially empty environment. We don't like to think of arenas ever being empty, but in a lot of cases they are, where we only have a partial house. And in a partially full house, the underseat or the in-rail deployment really relies on the fact that you've got to have human bodies there to create enough loss to keep that signal from propagating all throughout the domed environment and causing that reflection that we talked about earlier. And so if you have a half-empty house, then what you'll see is that where the access points are not are in an area where there's no people, then those access points cause a lot of interference. And in order to maximize the performance of that network, you really need to shut those access points off. And so our approach is, instead of worrying about that, instead of having that where you have to worry about crowd size, by pointing our access points at the down and keeping them as isolated as possible, we create those microcells, the same type of environment as having an access point under the seat, but we gain a couple of things. Number one is we don't have an access point underneath the seat, so it's underneath the seat is dangerous for liability purposes. It's expensive because that's the most expensive place to go, and so we put our access point above and away from the fan where they can't touch the technology. Number two is it also has better visibility to the device. If you think about if we're shooting from above, then at maximum we're shooting our RF signal through maybe 2, maybe 3 people in order to get to your client device, versus an underseat or an in-rail, you're usually shooting through 4, 5, or 6 to get to the access point. So there's just too much loss there. And then lastly, that also shooting from above helps to solve the partially filled arena, because in a partially filled arena, if you're shooting that signal down, then it's not nearly as intrusive if it's an empty section, as opposed to having omnidirectionals that are under seat or in rail that don't have people to absorb that RF. So you get a much cleaner RF environment in a partially filled environment when we're able to shoot down directionally as well.
Excellent, thank you. Last question is kind of a two-parter. Is there a cost associated to the software? If it's free, is there a paid service that would give me better support or user experience?
Great question. Right now, the software is completely free. So the software can be downloaded and installed. And the reason that we're doing that, to be honest with you, is to give ultimate flexibility. So a lot of, especially in this environment where you're talking education and hospitality, a lot of times your managed service providers are looking for ways to maximize their service and maximize their profit. So we offer our software for free so that you can create your own cloud. You can have your own cloud-based controller and then turn around and make that a profit center for you and for your customer. And so right now there is no cost associated with that, no initial upfront cost and no long-term support costs. We do offer paid long-term support. That paid long-term support is honestly, it is on a case-by-case basis right now, and that is because right now our solution is honestly, it's so unique that we really prefer to have a hands-on approach with our customers. And so when we get into a large deployment, for example, because as we like to say, our solution is almost like an F1 race car. You don't just give that to a 16-year-old that just got their driver's license and let them go with it. There's some specific things that you need to know in order to tune and make sure that you drive that car correctly. And so we do have paid support options, but again, they're not standard. It is something that's negotiated for each individual user. And so I'd encourage you to reach out directly to me or to your Microcom rep, and we can discuss the individual applications.
Fantastic. Thank you, Ryan, so much for answering all of those questions. And also thank you to everyone for attending today. And if you have any further questions, of course, please feel free to contact your sales rep or email us at sales@microcomtech.com. And if you wish to view any of the products mentioned or shown today, please visit us at www.microcom.us. Also, please remember this webinar presentation has been recorded and it will be uploaded to our Microcom YouTube channel so it can be viewed again. Thank you, everyone. Thank you for joining today. Have a wonderful rest of your day. Appreciate it.